So this is a practice problem. So we're going to go through this question number 1, question number 2, question number 3, and then we have 4, 5, 6, 7, and 8, and then we move on to trigonometry. So in trigonometry, we're going to go with conversion and finding some trigonometric values under different type of problems, and then graphing trigonometric function and finding amplitude, period, and phase shift, and then finally we're going to discuss general functions. Those are topics that we're going to cover. So let's go one by one. From the first one, first one is about the composite function. Since we discussed this in the last exam and in one of the quizzes, I only do like one problem. So let's try to go that quickly. So question number 1, which is the composite function. So the composite function. So 4.1. So we know that the composite function is defined as f circle g. This is what we normally write f of gx. And then we also have a g circle f. This we're going to write as g of fx. Okay, so what function are you going to put inside is matters. So for example, let's do this question. So let's say you are given fx equal x over x minus 1 and gx equal square root x. So for this function, you can calculate, for example, f circle gx. So that means you're going to put the f function inside g. So in this case, since g is square root, we're going to put under square root x over x minus 1. So it's clear that x cannot be 1 because otherwise you can divide by 0 situation happens. But still you need to make sure that this one is positive or 0 because under square root that's what should happen. So that means for the domain, what we need is the inside function x over x minus 1 has to be greater than or equal 0. To do that, what we normally do, we can look for zeros. The zeros from the numerator is 0, zeros from the denominator is 1. So what we do, we mark them on a line in the increasing order, 0 to 1, and then we're going to pick test points. Okay, so the test points, we can pick t equal 2 here. So if you put t equal 2, if you plug in, you're going to get 2 over 1. That means both are positive, so it's positive. And we can pick t equal 0.5 here. If I can 0.5, this is positive and this is negative, so it's negative. We can put t equal 2 here. If you plug in 2, you get 2 over 1, so which is positive. So that means we are looking for positive or 0. That means we need this and that, but still we want to make sure that we avoid dividing by 0. That means you remove the 0 from the denominator, which is 1, so you remove 1. Since there's an equal sign here, you're going to include the 0 from the numerator. So that is the solution. So that means the solution set is this one, because we are looking for positive. So that means we can write the solution like this now using the interval notation. So this is d, the domain of f circle g equal negative infinity all the way to 0, including 0, union, we remove the 0 from the denominator, so it is 1 to infinity. So that's the domain. So this is how you do a typical problem. And if you need more, you can look at the click the link, and you can see I have solved all 4 problems in the video. So you can look at complete solution for it. Okay, so let's go to the second question. So 1 done, 15 more to go. Okay. Question number 2. Question number 2 is about one-to-one functions. One-to-one functions. So what's a one-to-one function? We know that when you have 2 domain, like a domain and a range like that, we try to avoid this situation. But this situation, you're going to start with different x values, but unfortunately, you end up with the same y value. So this is what we normally call So this is not 1 to 1 because you see the 2 goes to 1. This is 2 to 1. So we try to avoid this. So why try to avoid this means if you know that the output are the same, you want to make sure that the input are the same. Okay, so that is the definition we use. So we can say if fx1 equal fx2, this should imply that x1 equal x2. So that is what we normally call the algebraic version. And then we also talk about that if a function is increasing or decreasing. If a function is increasing or decreasing, then it has to be 1 to 1. And the third one, we also look at the graphical version. That means you draw the graph and then we use the horizontal line test. Horizontal line test. Those are the 3 ways to check whether a given function is 1 to 1. Okay, let's try to also look at some special cases. For example, we remember the exponential graph. Like for example, if a is greater than 1, you get a graph like this. It's increasing function. So this is the graph of y equal ax when a greater than 1. And you can see if you use any horizontal line, it only cuts at 1. The reason is function is increasing. There's no way that it can cross it again because the function is completely increasing. So it never can cut again. Okay. Also, if you look at the other function like the for a between 0 and 1, which is a decreasing function because it's a fraction, so it's going to go down. And again pass through 1. This is one, and you can see that still the horizontal line test works because it's going to cut only at once. And then if you look at the inverses, the inverse of the exponential function is a logarithm. So it's going to go like that. To get that, you can look at the reflection across this y equal x line. That's what we normally do in the geometric way. So this is the log function. This is the y equal log ax. A for a greater than 1, and if a less than 1, we're going to get the other graph. So if a less than 1, the reflection of this one, so that means you're going to get a graph like that. So that's again a log ax, that here a is in between 0 and 1, and you can see that again the first this one is the increasing function, this one is a decreasing function, so they are all 1 to 1 functions. This is something we can remember. It's going to help you a lot. Okay, they are all 1 to 1. Good. So let's do a problem like this. So I'm going to do 2b. 2b. So if you do 2b, so you're going to get, this is a problem. It says that solve a gx equal x plus 2 cube. So show that this is a 1 to 1 function. Okay. So we're going to use the algebraic version for that. So what's the algebraic version? We can assume gx1 equal gx2. The goal is to show that x1 equal x2. That's your goal. Show that x1 equal x2. And so that means we're going to say we're going to plug in x1. That means x1 plus 2 cube equal x2 plus 2 cube by the definition. Now we know that the cube is a 1 to 1 function. That means the input values should be the same. Because why is that? If you look at the graph of x cube, it looks like this. It's a graph of the cube function. And you can see that this is a 1 to 1 function. It's increasing function. So this is y equal x cube. This is a 1 to 1 function. That means since the function is 1 to 1, the input value should be the same. All right? Good. So also, if you take the cube root, so you can say taking a cube roots, 3 get cancelled. You end up getting x1 plus 2 equal x2 plus 2. Now when you cancel 2, you can see that you end up getting x1 equal x2. That's exactly what you want to prove. You prove that x1 equal x2. If you assume gx1 equal gx2, you end up getting x1 equal x2. So that means by the definition, G is 1 to 1. Okay, that's a algebraic way to show that this is 1 to 1. Good. Let's try to do one more example. Let's try to see C is hx equal 3 e to the x minus 1. How to show that this is 1 to 1? So we can do this problem again as we did before. So if you do that, I'm going to do it here. We can assume that hx1 equal hx2. That means 3e x1 minus equal 3e x2 minus 1. You're going to cancel 3. Then you get e x1 minus e x2 minus 1. Now we do the interesting trick that is try to solve exponential function, take in log. So we're gonna take in ln, the natural log of both sides. What happened? The exponential part comes out. So that means you're gonna get x1 minus 1 equal x2 minus 1. If you add 1 to both sides, x1 equal x2, that's exactly what you want to show. So the algebraically you can do it like that. So but let's try to do the how to do like a increasing decreasing version. We know that the base here is e, right, which is like 2.71. That means it is more than 1. So we can say since e is greater than 1, the exponential function hx is an increasing function. Increasing function. Since the increasing function, this has to be 1 to 1. So it is 1 to 1. So that's the easiest way to do it. Just like you say it's an increasing function because e is greater than 1, so it has to be increasing, right? Because this is just a horizontal shift. It doesn't do much. It's just scaling. It doesn't do much. So it's just increasing, right? But it's just a shifting. Shifting doesn't change. It's still increasing. Okay, but if you have negative 3 here, what are you going to do? Instead of 3, you have negative 3. What will happen now? Instead of 3, if you put negative 3, huh? What's the negative sign does? You're going to flip. Oh, that means it's not increasing now. It is decreasing. Still 1 to 1. So it doesn't change much. Okay, but it's decreasing. It's not increasing because this graph go up, but now it's going to go down. Okay, so good. So for this one, it's increasing function. So that's what you have to write. I mean, that's you're done. Okay, but this is a little long. Okay, so that's about that. So the major part was we know that if a function is increasing or decreasing, it is 1 to 1. So that's the property we use here. Okay, good. Question number 3. Question number 3 is about finding inverses. Find the inverse. Anyone remember how to find inverse? Four-step method. Exactly. We use the four-step method. Four-step method for fx equals something. Okay. Four-step method. What are the 4 steps? What's the first step? Replace fx by y. The second step, interchange y and x. Third step, what's the third step? Anybody, what is the third step? Solve for y. What's the fourth step? Replace y by f inverse x. That's the fourth step. So so we use the four-step method. So I'm going to do just one of them. Let's do part D. Okay, part D. That's what I did for. I'm trying to do the same thing for all the classes, so it's be fair for everyone. So D is Rx equal 3 over 2x minus 5. That is Rx. So we're going to ask you to find the inverse of this function. But we know that this function is a one-to-one function. You can show that using any of those methods. Okay, so the easiest is we can use the algebraic method. You can easily show that this is a one-to-one function. So this is a one-to-one function. Okay, so the inverse exists. Inverse exists. So we're going to find that inverse. Okay. So we're going to start with Rx, which is 3 over 2x minus 5. The first step, you replace the function by y. The second step, switch x and y. So x equal 3 over 2y minus 5. Solve for y. So to solve for y, because you're going to reach y as fast as you can. So the best thing that you can do, I mean, there are two ways to do this. First, one method is crossover, like you can cross multiply. The other method is, what I'm going to do here is I'm going to flip over. It's much faster. So I'm going to flip this. Once you flip, this is going to be 1 over x. If you flip this, this is going to be 2y minus 5 over 3. Right? Now you can see y is on top. So it's much faster now. Okay, we're going to solve for y. So now what I'm going to cross multiply. I'm going to multiply both sides by 3. So this is 3 over x equal 2y minus 5. Can someone tell me what's the next step? What's the next step? Add 5. Okay. So we're going to add 5. So that means it's 3 over x plus 5 equal to y. What's the next step? Divide by 2. So it's y equal, if you divide by 2, it's going to be 3 over 2x plus 5 over 2. That's it. Okay. Now what we can do, we can write this answer as R inverse, which is equal to 3 over 2x plus 5 over 2. So that's the inverse function. Okay. So it's not that difficult, but there are certain steps that you have to do. Okay. That's how we do for any problem like that. This is a 4-step method. So let's go to question number 4. Question number 4 is about solving exponential functions. So I would like to do part D. I would like to cover all questions, like at least one from each type. So solving exponential functions.
What part you said this was?
Question number 4. Oh, solving exponential functions. So if you look at the video, if you have exponential function, there are 4 types of exponential functions. There are like a 1 exponential term, 2 exponential term, more than 2 exponential terms. And then out of those 3, we also have same base and different bases. Okay. So that's how I kind of break the video, so you can look at that and understand more steps. But I'm going to do just one of them. So I'm going to do part D. Okay. There are 4 different types, the same base and different bases. And then when you have different bases, there are also 2 types. One type is you can bring it to the same base. That's one type. The other type is you cannot bring it to the same base. For example, 2, 3. There's no way you can write one from the other. But if you have 2, 4, you can write one from the other. So those are the 2 different cases for the same base and different bases. So let's look at a problem like this. So let's say solve, let's say 2x squared equal 4 to the x over 2 plus 3, problem like that. Can someone tell me what is the starting point? You see that different bases, but can you bring it to the same base? Doing what? Noticing that what? Yeah, how you do that? Exactly, we notice that 4 equal 2 squared. That is the starting point. So we can replace 4 by 2 squared. So we can write this one as 2x squared equal, we replace this one by 2 squared. And then x over 2 plus 3. Now you can see that it's a power of a power situation. We know from algebra, if we have a power of a power, what we normally do, we're going to multiply the 2 powers. We do the same thing here. So we're going to multiply the 2 powers. That means 2 to the 2 times x over 2 plus 3. Just multiply the 2 powers, right? So we can simplify. That means you're going to 2x squared on this side. This is 2. When you multiply, you get x plus 6. X plus 6. Okay, now you can see that same number, same base, exponential has to be the same. The reason is, you can say since y equal 2 to the x is 1 to 1. That's the reason. Since it's a 1-to-1 function, whatever you plug in has to be the same. Okay, so we're gonna set the index equal x squared equal x plus 6. The reason is the exponential function is 1 to 1. That's the reason. Okay, so we're gonna set them equal. Now this is simply algebra problem. You're gonna bring it to one side. X squared minus x minus 6 equals 0. We're gonna factor this. The factors are x minus 3 and x plus 2. This is going to give you solutions as x equal 3 or x equal -2. And you can see both works. So that's a solution. Okay, so that's a whole problem. It's not difficult. There are certain steps that you will remember. Huh? All right. This is like one of the easiest questions actually. It can be complicated maybe more than that, but this is like a straightforward one. Okay. So number 5. Graphing exponential function. Graphing exponential function. So let's do question number B, 5b. So which is y equal 3 minus 1 over 4 to the x power. 3 minus 1 over 4 to the x power. Okay? The exponential function. So you can rewrite this question in 2 different ways. So one way to write this one as 3 minus 4 to the negative x. Then we can go with step-by-step process because we know what's the graph of 4 to the x. That's like almost ex. Flip over across the y-axis. Flip over across the x-axis. Add 3. Right? That's one way to do it. But there's a shortcut. But the shortcut, we can write this one like this also. We can write this one as 1/4 to the x power. If you do that, now you need only 2 steps. Because we know the graph of this already. Because this is like y equal ax, a is a fraction, so the decreasing function. So we can stop because you need 2 steps. So we're gonna go with that. So y equal 1/4 to the x one, because we know that the 1/4 is in between 1 and 0. So that's the decreasing function, the fraction. Since a fraction, it's gonna decrease.
You can't see it.
So so it's gonna decrease. So this is going through 1. So that's the graph of y equal 1/4 x. So the next step, you're gonna flip over. So we're gonna say y equal negative 1 over 4x. What's the negative sign does? You're gonna flip over the graph. Okay, I mean it's gonna go like this now. This is negative 1. It's still the asymptote is there. And then finally, y equal 3 minus 1/4 x. That's gonna add 3 to the graph. That means you're gonna move whole graph 3 units up. So that means what happened now is you're gonna move this 3 units up. The asymptote now goes to 3. It has 0. It goes to 3. And then the negative one, if you add 3, is gonna go to 2. That means your final graph is going like this. Okay, that's a graph. Okay, so if you go like that, I mean, it shouldn't take too long. Okay, but you have to go like step-by-step approach. Good. Question number 6. I'm going to do 1b. So question number 6 is about expanded version and the condensed version. You can combine condensed version and the expanded version of the logarithmic ones. So let's do the condensed version. So I'm going to do 6(1)b, which is about log x plus 1 minus 1/2 log x squared plus 1 plus log x. When you talk about log, we know that if there's a sum, that means you're going to multiply inside. If there's a difference, that means you're going to divide inside, right? So that's exactly what we're going to do. What base? What's the base here?
10.
Base 10. Okay. So, so before we do that, we need single terms. We can have terms like that. I mean, if you see a term, you're going to bring it inside. But you know that when you bring it inside, it's go as a power. Remember the power out formula? So it's a power out. Now we're going to power in. So we're going to power bring as a power. That means we can write this one as log x plus 1. If you bring the power inside, this is going to be log x squared plus 1 square root. And this is going to be log x. Now there's a sum, that means you multiply. There's a difference, that means you're going to subtract, you're going to divide. That means you can write this one as log, you're going to multiply these two. So x times x plus 1. And it's a minus sign, that means you're going to divide by that. So that is the condensed version of that. Since it's a fraction, you don't need a parenthesis, but you can if you want. But if it's a multiplication, you have to put a parenthesis, otherwise it has a different meaning. If it is a fraction, you do not need this option. Okay, that's the condensed version. I'm not going to do the expanded version because that's the easy one. For the easy one, I'm going to give you this. I ask you to write this one. Okay, so I'm going to let you try that. Okay, let's move on to question number 7. So 6 done, 10 more to go. Okay, okay. Question number 7. So solving the log equations. Solving the log equations. Again, when you talk about solving log equation, there are 4 different types. Okay, there are equations with 1 log term. There are equations with 2 log terms. There are equations with different bases and the same base. Okay, there are 4 different types. And if you look at the video, you can see that I have divided that into all those 4 different types so that it is easy for you to understand. Okay, so if you get a chance, look at that. But I'm going to do one of them here just to save time. So I'm going to do B. Okay, question number B, which is solve log 2 x minus 2 plus log 2 x plus 1 equal 2. So, so one thing we know that the graph of the log function looks like this. Pass through 1 and increasing function. There's asymptote here. That means the domain is only from 0 to infinity, right? So I mean, we want to make sure that that's the case. That we want to make sure that this is positive and that is positive. So that is the starting point for log function. So we can write, we can check, we can find the domain first. So for the domain, okay, for the domain, x minus 2 has to be positive, and it's an and, it's not an O, and x plus 1 has to be positive, because this has to be positive because it's only defined for that. This says that what? It says that x greater than 2, this says that x greater than negative 1. So what does that mean? That means what? That means x greater than what number? This is x greater than 2. This is greater than negative 1. So x greater than what number? Exactly, x greater than the larger. Okay, for example, if you say I have $10, or I can say I have $1, right? So, but if you say I have $10, it means that I also have $1. That's the same argument here, right? So it's larger than the larger. Okay, remember that. Okay, that means x has to be greater than the larger one. That means if you get any solution which is either equal to 2 or less than 2, it is not the solution. It is not in the domain, right? Good. So, 2 terms, you're going to combine to make it one term. That means you're going to multiply inside. So you can write this one as log 2. You're going to multiply inside. Since there are 2 terms, I put a parenthesis. So x minus 2, x plus 1 equal 2 on the other side. Is that right? Combine. Now we can distribute inside. If you distribute inside, you can get x squared minus x minus 2 equal to, right? Now we can write the exponential form. Okay, so rewriting in the exponential form, you can write this one as x squared minus x minus 2 equal, the base is 2. So 2 to the 2, right? 2 to the 2, which is 4. If you bring everything to one side, you can write this one as x squared minus x minus 6. You can see this is the exact same problem we solved earlier. So the factors are x minus 3 and x plus 2. The solutions are x equal 3 or x equal negative 2. What's the problem now? What's the problem now? Both less than 2? Oh, I'm sorry. This is positive 3. So yeah, you can see that this is not a solution. Okay, so since x is greater than 2, x equal 3 is the only solution. Okay, so if you also write x equal negative 3, you lose points. Okay, you lose about 2 points if it's out of a 10-point problem. Okay, because you cannot. Well, I'm asking the solution. You can't give something else, right? Yeah, I'm asking you to drop me at Chicago. You cannot drop me at New York. Okay, you can do that. So that's the argument. You know, if you want to look at that in day-to-day life terms, that's what it means. Okay, good. There's only one solution. Good. So I go to question number 8. So I'm going to do part A. This is a graph in logarithmic functions. So let's say y equal 2 minus 3 ln x. So this is a basic, like, easy function, step by step. We start with the log, multiply by negative 3, add 2. Okay. So we're going to give y equal ln x. So that is the basic graph that we remember. Everyone know this graph now. And then negative 3. So y equal negative 3. What it does is going to flip over and scale by 3. Right. So nothing much happened here. So it's going to flip over and scale. So it's going to look the same. It's going to like stretch. So it will be like this. Still 1 here. Still 1. It's only scale. Okay, you can stretch. Okay, and then add 2. So it is 2 minus 3 ln x. What this does is going to add 2. Okay, if you add 2, what will happen? This point move up here to 2. That's what happened. So the final graph is still at negative 1. It's going to go to 2. So it does move here, and then so it's the same graph, but it's going to go like this. Okay. Good. So that's the final graph. Good. Okay. So that's the exponential, all the exponential and logarithmic functions part. Now we're going to go to trigonometry. In trigonometry, that's chapter 5. First one was conversion. In the conversion, we can talk about 2 types. We multiply by pi over 180. Can someone tell me this we do to convert to what? When you multiply by pi over 180, convert to what? Radian or degrees? Huh? Okay, how you remember? It convert to what is on top. So it convert to radian. Convert to radian. That's how you remember. Okay? And then if you do 180 over pi, it convert to degree, because that's what on top. Because that's where you end up with, because that's a numerator, right? So that's how you remember. Convert to degree. Since this is an easy one, I'm going to leave it for you. Let's do something difficult. Okay. So this is easy one. You multiply by this to convert to radian. You multiply that to convert to degrees. Just remember, is what is on top. What matters. Okay. Good. Let's do number 10. So number 10 is about like I give you a point and then ask you all those 6 ratios. Okay. So for example, let's say you have negative 3, 5. That's someone asked from my morning class. So I'm going to do the same thing for everyone. Okay. So what do? You draw the point. Okay. What quadrant? Second quadrant. Why? Negative x, positive y. the second quadrant, right? So we're gonna go to second quadrant and we draw the point. So it's -3 and 5. So let's say it's here. So this is -3 and 5. So that's the point. That means that is the angle we are talking about, theta. Good. What we normally do, we drop the perpendicular to the x-axis and then try to find the missing legs here. This is -3. This is 5. You're going to find r. You can use a Pythagorean identity to do that. So it's 5 squared plus -3 squared equal r squared. This is 25 plus 9 equal r squared. So r equal what? This is 34. 34 square root. We only pick the positive one because r is the radius, which is always positive. Good. Since you know all three sides now, you can find any ratio you want. Okay, so let's go with sine theta, which is y over r. Y means 5 over r means 34 square root, and we leave it like that. We are not going to go for rationalizing. We don't do that for trigonometry. Okay, and the cosine theta, which is x over r. So x means -3. We put the negative sign in front over r 34. And the tangent. Tangent means y over x. So y means 5. X means -3. Now we go with the reciprocals. So the reciprocals are cosecant theta. This is CSC theta. This is 1 over, that means 34 square root over 5. Secant theta, which is 1 over, again is a negative, 34 over 3. And the cotangent is also negative. We normally have the negative in front, so it's a 3/5. Okay, those are the 6 ratios. Very simple. You have to remember the definitions of sine, cosine, tangent. Sine means y over r, cosine means x over r, tan means y over x, and then flip over to get the other ones, right? Good. So let's go to question number 11. We have 6 more to go. Okay, we are done with 10 questions. So the next one is about a basic finding exact value questions. Okay, if you want to find exact values, you have several methods to do it. You can use a circle version, right? You can use a triangular version, or you can use the reference angle method. I'm going to go with the reference angle method because that's the fastest. Okay, so if you want to use the reference angle method, you need to remember a few things. One is the ASTC. This says that what is positive, right? Also, their reciprocals are positive. A means all, sine, tan, cos. Reciprocal of sine, cosecant, reciprocal of tangent, cotangent, reciprocal of cosine, secant. They are all positives, right? So we just write one of them, and the reciprocals are also positive, because when you take the reciprocal, it doesn't change the sign. Stay the sign. It's a negative, still negative. Like -2, -1/2. Reciprocal of each other, they are still carry the same sign. Okay. Good. And the other thing is, for any function, any trigonometry function, f theta equal plus or minus f the reference angle. So that is the only formula we use. That's a reference angle. And then the other one is the common table. Remember the common table? We have angles here and sine, cosine, tangent. So this is sine, cosine, tangent. These are the angles we go. So this table you have to remember. Okay. So I'm not going to write the table here. That's it. If you know those 3, you can find any trig function. That's the benefit. So let's do 1. I'll do 2 actually. I'm going to go with tan. Tan -5 pi over 6. Can someone tell me where this angle is? What quadrant? -5 pi over 6. What quadrant? Huh? Yes. You're right. It's 3rd quadrant. Why? If you have 6, 6, that means pi, but negative means what? Clockwise. Clockwise. If you have pi, it is exactly on there, but it's like 5. That means not even covered. So that means if you draw the angle, so for this problem, you have to draw the angle, okay? So that's the angle. So that's the angle we are talking about. So this is -5 pi over 6. Can someone tell me what's the reference angle? What's the reference angle? Huh? How much more you need to go have, like, get a straight angle? How much more you need? How much more missing?
30 degrees.
Just this part is missing. Pi over 6. If you add these two, you get full lines, right? So that's the reference angle. So that means what the theory says tan negative 5 pi over 6 is exactly equal. Okay, what sign? This is a tan in the second quadrant, plus or minus? It's plus, because it's a tan in the second quadrant. Tan the reference angle, that's what the theory says. This is simply coming from the table. How much tan pi over 6? Can you remember? 1 over square root 3. If you do not remember, this is the time to remember. Okay, it's to be too late. Okay, D. Because you know, problem is that easy. Okay, if you do it like that. Secant negative 5 pi over 4. What quadrant? What quadrant? It's in the second quadrant. It's a negative, but it's more than pi. See, it's more than 5. It's not 4, it's 5. That means you pass the line. That means you are in the second quadrant. You're right. So you are here. You go like this, right? So this is negative 5 pi over 4. So the missing angle, how much missing? Pi over 4 is missing. So that means, you know, secant is not, we don't know. What we do, we're going to convert this into cosine. Now we're going to use the argument. In the cosine, we need. You see the second quadrant, cosine, plus or minus? It's a cosine in the second quadrant. So plus or minus is a minus. Okay. So it's a minus cosine the reference angle, which is pi over 4. This we know, the table value. So negative sign, we write it here. So 1 over how much? 1 over square root 2. So 1 over 1 over, that means it will be square root 2. That's it. Okay. So negative square root 2. Okay. Number 12. Number 12 is about like a similar type of questions. So what we're trying to do, we're going to give you some conditions and you're going to figure out where the angle is. So like, for example, like this, that's number 12. So you're going to give you something like that and you're going to give some conditions and then you're going to use these to find where is the angle and then you draw the triangle, find the rest, right? That's the type of questions we're going to do now. So let's do C. So C is telling that cosine theta equal 1/4, that is given, and the cosecant theta is negative, that is given. So if you know that the cosecant theta is negative, what we know? We know it's reciprocal, sine is also negative. Okay? If cosine positive, sine negative, what quadrant? So what this means, cosine positive means angle has to be in these two. Sine negative means angle has to be in those two, right? So that means what is common? This, that is common. So that's where the angle is. Okay. So your angle is in the fourth quadrant. So we draw the angle in the fourth quadrant like that. That's the angle theta. We drop the perpendicular. It's a cosine. Cosine means adjacent over hypotenuse. So adjacent is 1. Hypotenuse is 4. So depending on the positives, negative, you have to put in the right place. If this was tan, if I had given tan, you want to make sure that you put the negative sign to this one, not to that one, because that's positive. So that's how you figure out where you're going to put it. Okay, if I given tan in the second quadrant, you're going to put to the y coordinate, the negative sign, this one positive. Okay, so it's depending on where you put. Okay, whether it's a negative or positive. Okay, good. Now you need to find the y. To find the y, we can use the Pythagorean identity. So y squared plus 1 squared equal 4 squared, which is 16. So y squared equal 15. So y is, you can see positive or negative square root 15. But since it's a negative square root 15. That's what you get y. Okay, since we know all three sides, you can find any ratio you want now. So we can do that. So we can write sine theta is a y over r. That means negative square root 15 over 4. We can also find tan theta, which is y over x, which is negative square root 15 over 1. And then you can find the other three taking the reciprocal. All right? So you can do that. Question number 13. Question number 13 is about graphing sine cosine. Okay, so let's try to do one of them. Question number 13. Is a graphing sine cosine. So for example, what is the graph of y equal negative 2 cosine x plus pi plus 1? Let's try to find the domain and cosine first. It's a sine cosine, that means domain is all real numbers. And the range. To find the range, what we can do, we're going to use the shortcut method. For the shortcut, we know that the cosine function with any x inside is a pi, is in between 1 and negative 1. That we know. Then we're going to multiply by negative 2. When you multiply by negative 2, this side become 2, this side become negative 2, and also flip the sign. That means you can write this one as negative 2, negative 2 cosine x plus pi less than or equal to, after flipping the sign. Now what we can do, we can add 1. When you add 1, this becomes negative 1. This is simply y. If you add, you get 3. So that means the domain is, range is from negative 1 to 3. That's a shortcut. You can just do that algebra like that. Okay, the graph. Graph, we're going to go by step method. We're going to start with the cosine graph and I'm going to horizontal shift, multiply by negative 2, add 1. We're going to go step by step like that. So we start with y equal cosine, only one cycle, one period. That means it's going to go from 0, pi, 2 pi. We know the cosine graph start at 1, go to negative 1, end up at 1. These are the halfway points. So the graph going to look like that, go like this, go down, go like that. So that is the graph of cosine for one cycle. Now what we can do, x plus 5 shifting. So y equal cosine x plus 5. Can someone tell me what will happen? If you do x plus pi, what will happen? What this can do? Shift into what direction? Huh? It's to the left, it's opposite. So it's going to go pi that way. So you're going to move this graph pi. That means 0 goes to negative pi, pi goes to 0, 2 pi goes to pi. So that means your graph going to look like this now. So it is negative pi, 0 and pi. That's what happened. You shift. That's 1 goes here. This negative 1 goes there, and the 1 goes there. So that means this is a halfway points. That means your graph going to look like this. Okay. Again, still between 1 and negative 1. The next step, you're going to multiply by negative 2. So y equal negative 2 cosine x plus pi. What that does, you can scale and flip over. Right? Flip over and scale. That means graph is between different values now. It's between 2 and negative 2 now, because you can scale it. And also flip over, no change to these values. Now flip over, that means 1, now we'll go to negative 2. You can scale and flip. The negative 1 goes to 2, and the 1 goes to negative 2. That means, and it's also the halfway point. So graph can go like this. And the final step, y equal -2 cosine x plus pi plus 1. What this 1 does? Bring up 1. So I mean, you're going to lift the whole graph up 1 unit. So we might need a fake axis now, because we're going to move. So we're going to draw this as a fake axis. So this is your original x-axis. This is, we need -pi and pi. To help the graph, we can draw a fake axis which lifted by 1. That means it's going to go at 1. That's your fake axis, just to get the help. And then this 2 goes to 3. -1 goes to, -2 goes to -1. And then we think this is your x-axis. And then this is the halfway points here. So we're going to graph the new one here. Okay, so you're going to start with -1, go to 3, and end up with -1. So the graph is going like that, go through this point, go to 3, go through that point, go to that. So that's the final graph. Okay, step by step. So it's straightforward. We didn't do anything new here. It's the same transformation techniques that we talked about more than 1.5 months ago. Number 14. 14 is about standard sine cosine. So a sine omega x minus phi plus d. This is a standard sine function. Standard cosine function is a cosine omega x minus phi plus d. Okay, if you get a standard function like that, there are a few things to remember. The period is always 2 pi over omega. This is omega. Sometimes you have to take absolute sign if this is a negative number. Phi is the phase shift. If phi is positive, now it's going to go to right because there's a negative sign already near. If phi is negative, it's going to go to the left. Okay, and the A is the amplitude. So let's do B. B is y equal 5 cosine 3x plus pi plus 2. So you can see that this is not in the standard form. Yep.
The phase right there, this says phase less than 0. Is that 0?
Yeah, this one 0.
That's a 0?
Yeah.
All right.
Positive, negative. Right? Positive, negative. So this is not in the standard form. That means you have to bring it to the standard form. Standard form is you write it like that. So that means you have to take 3 as a factor. If you take 3 as a factor, means you divide everything inside by 3. That's the first step. Second step is you to rewrite with a negative sign. So it is 5 cosine 3 x. You put 2 minus sign. Once you do that, you can see this is the phase shift right there. Okay, so you can write the period, which is 2 pi over omega, which is 2 pi over 3 in this case, is the period. And then the phase shift, which is -3. And the A, the amplitude, which is the absolute value of the term in front, so which is 5. Okay? That's going to be the easiest question that you can do. Okay? In the exam. There will be a question like that. I will just ask you to find those. No graphing. Okay? Graphing will be a different question. Question number 15. Question number 15 is the one we did the whole day Friday. So I'm going to leave that for you. Okay? Because we did a lot of examples there. So I'm going to say Friday. Okay? That's the one Friday. It's in the video, everything that we did. We talk about all those type of special graphs, like how to graph tan, and then how to graph the standard functions. I'm going to skip that because I'm going to go to chapter 6 because that we covered through the video Monday. 6.1. Okay, it's only 6.1. I'm not going to put 6.2 in the exam. Okay, that we discuss in the video next Monday videos. Okay, for 6.1, we again need the same table that you learned a few minutes ago. The table, sine cosine table. It's the same thing, nothing new. So let's look at the sine situation. So sine graph looks like this. Okay. So the problem is this is not a one-to-one function. See, you're going to cut at more than 1 point. So what we do, we're going to make it one-to-one. How to make it one-to-one? By restricting the domain. There are so many ways to do that, but this is the one we're going to pick because this is closest to 0. You can also pick, if you don't like it, pick this. That's fine. Okay, but it's far away, so it's difficult to do the problem. So what we do, we pick this one. It's very close to 0. It's easy because it go between negative pi over 2 and positive pi over 2. It's very symmetric and neat. So that's why we pick that special domain to make it one-to-one so that the inverse exists, right? So those actually all 6 functions have inverses. We write it like this: y equal sine inverse. That's what the video explain. Okay, so make sure you at least watch the video once because there will be questions very similar to those. Okay, don't wait until tomorrow, it will be too late. You try to find some time today to watch that, and then you will much comfortable after you do that. This is a topic like students find difficult, like for pretty much everyone. Okay, even the very good student also find a little difficult here. Okay, so it's like a common thing. Y equal sine inverse x and y equal cosine inverse x and y equal tan inverse x. So we pick sine inverse range where the cosine positive. That's why we pick this. So that means the domain is simply between positive pi over 2 and negative pi over 2. That is where the cosine positive. For the cosine, we're going to pick the place where the sine positive. That is why we pick for for the cosine inverse between pi and 0. That's the reason. And then for tangent, we again pick the place where the cosine positive. That's the reason we pick the domain range as okay. Actually, there's no equal sign. So that's the only difference. There are no equal sign. Okay, there are no equal sign. So it is from pi over 2 to negative pi over 2. So that's the first thing. Okay, where you define sine inverse, you define from negative pi over to positive pi over 2, including the corners. Cosine you define where from 0 to pi, cosine inverse. Tan inverse you define from negative pi over 2 to positive pi over 2 without the corners. Okay, and then also we have this inverse property. Remember the inverse function property? That means if you take the inverse, you get the function back, the x back, but it's not exactly correct here. For this one, you want to make sure that this x is inside here. Okay, that means x has to be inside negative pi over 2 to positive pi over 2 to cancel out. It's like the cancel out. See, you cancel out, you get x back. By only here. If you're outside, you can't do that. And then you switch the two, sine and sine inverse, but this one is easy. This is just x has to be between 1 and negative 1. That we know. For sine is between 1 and negative 1, that it should be the case. Okay, that's it. Those are the only theories, major theories for these functions. Let's do 2 short questions. The first one is sine inverse sine pi over 13. What's the answer? Your sine inverse pi over 13. Exactly, because the reason is pi over 13 is inside here. Okay, so you just get that. That's the answer. But what about the other one? Like something like this. That's the last question I'm going to do. Sine 5 pi over 6. Unfortunately, no, that's not. No, because it is not. The reason is this is not here. That means you have to convert this into an angle which is there. What we can do, we can use the reference angle method. Where is this angle? What quadrant? What quadrant? Second quadrant, right? So what's the reference angle? Pi over 6. So that means this is a sine. Since the sine, we know that it is exactly equal to positive because it's the second quadrant. So it's positive, the reference angle. Is that right? But what do you know about this angle? This is in the domain. That means we cancel out and get the answer as pi over 6. See, these answers are not equal because this is outside of the range. So that means you have to bring it to something inside. We use the reference angle method. Now you can cancel. So cancel out angle. So that's why you get the reference angle as the answer. So that means this answer is plus or minus the reference angle. Yeah, so depending on, yeah, it's always depending on where this one is. If it is in these two, it is minus pi over 6. If it is on this, is if in those two, it is plus pi over 6. Okay, good. So that is the end of the review. I hope this will help you go over this again. And my plan is to post the complete solutions to reference sometime tonight. Okay, because I had to go home and record it and print it. Okay, good. See you Friday.